We want to make this as valuable as possible for everyone here. So please feel free to drop a chat as a technical question comes up. We want to make sure this is something where you're walking away with concepts completely explained, feeling like you've gotten inside the head of an engineer, understanding how they think about privacy and how that relates to how you might think about privacy from the legal or operational side of the house. And we're joined with two great guests who can do that so well for us. So we'll start with just some introductions. Pilar, do we want to start with you and then we'll head over to Ben?
Sure. Hello, my name is Pilar. I am privacy officer for 1Password. I've been at 1Password for about 5 years now, and I've been dealing with privacy-related things almost from the beginning of us going from having just local versions of the apps into having a hosted service, which means a huge increase of data. And then, all the privacy regulations, the GDPR, and recently also a huge growth and changing needs from different business units in the organization. So it's been pretty exciting, and thank you for having me here.
Thanks, Pilar. And great, Ben, over to you for a quick introduction.
Great, thanks. Good morning, everyone. My name is Ben Brook. I'm the co-founder and CEO here at Transcend. For those of us who don't know, Transcend is a data privacy infrastructure company. We work with other businesses to help them comply with privacy laws like GDPR, CCPA, and all the new ones that are coming up like CDPA in Virginia. What we build is infrastructure that helps automate any sort of process that comes with these new privacy laws, such as the right to erasure, right of access, and we're also expanding into other categories like consent, data mapping, and so forth. Really excited to be here and help decode the tech stack here. So good morning, everyone, and thank you.
Awesome. Thank you both. My role for today is going to be the non-technical decoder. I am not an engineer by training. So if I am not asking the question that is popping up for you in your brain, please just drop it into the chat. Let's make sure we cover off everything. We're going to put Pilar and Ben in the hot seat today with a lot of awesome questions and ask them to really break down some concepts for us. So with that, we'd love to just start with a warm up. We'd like for this to be interactive as a Zoom call. So if you could just drop in the chat, how you would rate your privacy engineering knowledge today? 1 being starting out, maybe you're excited, but just learning. 5, you're here to brush up. Maybe you've learned some technical concepts before, have a good sense of the engineering side of the house. But go ahead and drop a thought in the chat and we'll kind of follow along. And that will also help us make sure that we are calibrating effectively. So we hear a few 1s trickling in, some 2s. And this will be helpful for Pilar and Ben as they're thinking about how they're explaining the concepts as they go. Awesome. So keep dropping those in as you are thinking about how you would rate your privacy engineering challenge. And if anyone wants to hop off mute and just give us a little bit of a hello or a good morning, feel free to do so. I know we're all so accustomed to webinars these days, but this is a Zoom call, so we can also have some conversation as well. I'll just give a moment in case anyone wants to say hi or what brought them to this meeting.
Well, I'll say hello. Dana Wagner, Impossible Foods. The safety and security teams are part of my portfolio, and I don't usually respond to these these things, but this one looked interesting, and I thought it's a subject that it's always good to learn more about, especially as we think about more international expansion and having infrastructure in different places. And I appreciate you doing it. So, hi.
Awesome.
Morning,
welcome and good morning, Dana. Thank you for joining us. Well, great. Well, folks, feel free to jump in as we go. Again, my mission here is that you walk away with some really good insights on the engineering side of the house, but I also want to make sure we just jump right in because we've got a lot to cover. So we'll just quickly look at concepts we're going to cover today. In part 1, we're going to talk about why getting technical matters, understanding the value of how to really get in the shoes of your privacy engineering team, what makes them tick, what can frustrate them, everything in between, what motivates them. We're going to break down those because we know that aligning engineering resources is a huge part of the job of the privacy office these days. So we're going to talk about how to do that effectively and why it matters. In the second part, we're going to go into break down some actual concepts. So these are terms that you may hear your privacy team throw around. Perhaps they're discussing or breaking down data access or erasure requests and using some of this technology and terms. We're going to talk about what it means from the engineering side of the house so that you can come to those conversations more equipped. And then in part 3, we're going to do a speed round. This is really informed by questions we've received in advance of this session, but also feel free to drop questions as we go into chat, and we'll just quickly try to pop through as many as possible and also leave time for you all to interact as well. So let's keep this as interactive as possible. Want to make sure this is valuable for you. And with that, we'll go into part 1. Awesome. So would love to talk a little bit about why getting technical matters. So Ben, I'd love to start with you. When we think about the value of the partnership that needs to start emerging from legal and engineering and program management, what are some of the tangible benefits that you're seeing? And can you kind of break down what a strong partnership looks like from your side?
Sure. So, first of all, this is a very common problem that engineering and legal counterparts don't communicate very well. Part of the reason for this is they both speak their own languages, and they're both like highly esoteric, like domain expertise areas where lawyers went to school for a very long time learning the law. Engineers went to school for a very long time learning engineering concepts. And suddenly with privacy, with modern privacy laws, there's now this requirement to sort of like mesh these legal concepts with actual like really technical implementations where you're going into data systems, you're actually operating on user data, and there's all sorts of limitations on both sides and requirements on both sides that these folks have to collaborate on. So being able to sort of learn the other's language, at least to the degree that you can effectively communicate, is essential to actually getting through any of these projects. There are a lot of projects now. So it's like with GDPR, it was kind of the first time that privacy went beyond just like, make sure you have like an up-to-date privacy policy and that you're not like doing some basic things around respect for data. But now it's really like, okay, how do we delete a user everywhere? How do we export their data? How do we, gather consent? And a lot of these systems weren't initially architected with that in mind, right? So personal data may be stored across hundreds of different systems, and they may not be like nicely indexed where it's just a simple function that can be implemented. That function typically wouldn't exist at all. So being able to actually work closely with these teams is essentially just a necessity to being able to get through any of the modern requirements. And furthermore, you'll also just be able to have like a lot of upside opportunity where as you're building new products, you can actually implement them more thoughtfully. You can get around like implementing new tech debt you're gonna have to sort of backtrack and say, oh wait, but we forgot to like incorporate this part of this privacy law. And really just being able to think about like how to either implement new workflows on these requirements or actually implement new products and systems. Having that partnership will unblock you the whole way through.
That's great. And Pilar, when you think about the support and guidance that privacy engineers are looking for when they sit at the table with their legal or their operational counterparts, what are they looking for? What in an engineer's mind, what are you hoping for when you sit down at that table or get on that Zoom call?
In my case, and I think a lot of it will be true for a lot of us, is tons and tons and tons of details. The more details, the more specific, the more clarifications you can give us on what you need, the more likely it is that you're going to end up with what you actually want, that it's going to go faster because then we won't have to keep on coming back to you to get those details, and that we will all be happy with the end result. So if you say something like, oh, we need to erase everything, give me a list of the things you need. It can be everything from this particular system because we are not going to be using it anymore. Okay, that I can understand a lot better. But that kind of general or unspecific kind of wording is usually the biggest hurdle that I have.
So bring the details, get specific, make sure you're breaking down the concepts as you go to have a more productive conversation.
Yeah.
It sounds like, particularly on the legal side of the house and the engineering side of the house, both organizations are trying to make sense out of chaos and drive to as much clarity as possible. So that's actually great to hear, because I think that there's some really strong overlap between the two orgs and their ability to get into the details quite efficiently. And why would you say that getting technical matters? Why is it helpful for you guys? When we put together this event, you both said, yes, I have so much to say here. Why is that? Why does it matter for non-technical folks to learn a little bit more about the technical side of the house? What do you think that gets to as an end state, or where do you think that that can bridge some gaps that we're seeing currently?
Go ahead.
Sure. So a lot of this is there's like a conversation around risk, right? So compliance is really a function of risk, and with that comes like a lot of context on like where on the spectrum of compliance, where there's no real absolutes, are we going to sit? And to be able to actually understand like what the trade-offs are along the way, it's really important to actually understand like what the current state of a system is and what the limitations are. So for example, a backup, right? That's a very hard thing to delete personal data from. You could do it, but there's a lot of other trade-offs that would come with that. And so being able to like actually get into the weeds with an engineer and assess what the trade-off is to get like this tick further down the compliance spectrum, and like truly understanding that and being able to have that conversation, I think is essential. Otherwise, you don't want absolutists on both sides, where you could have legal folks saying we have to delete all personal data. That's a totally fair thing. But on the other side, you're also going to then have absolutists saying that's not possible. That there's some stores that we have that you physically cannot erase data from. And then you get nowhere. And so being able to actually understand and like have that conversation about like what are the technical roadblocks, like how high are they, and like can we have this conversation as two people in a room to actually assess what that trade-off looks like? I think it's really essential. And just at a high level, having some technical expertise, I think is, or not expertise, but at least being able to converse is really, really helpful in that conversation. And then conversely, you know, the engineers will very likely be trying to understand some legal definitions, like what is personal data? And so people have to sort of meet in the middle a little bit here, so that we can at least start speaking something closer to the same language. Yeah.
I love that. And I'm sure we'll have volunteers for lawyers who would love to help engineers understand their side of the house. We might have to do that as a follow-up because it's definitely valuable. I think this is a great foundation for us. We'll probably come back to some of these themes just to make sure we've unlocked exactly why getting technical matters. But let's move on to our next section and talk about some of the key technical concepts that engineers work with. And what's interesting is we've definitely seen an evolution here. When I first encountered privacy, it felt incredibly legal oriented, was focused on the understanding the regulatory components and the policies. And now increasingly we're seeing more and more concepts. So this is not a holistic view. This is just some of the top ones that come to mind, with things like access, deletion requests, consent, etc. But let's jump into our first one, authentication methods. So let's start with you, Ben. What different authentications methods exist today? Maybe kind of ground us in where you're going to encounter this along your privacy journey, how you think about it from an engineer's perspective, and some of the strengths and weaknesses.
Sure. First of all, authentication basically just means like proving your identity to someone, and then that someone letting you do things. So for example, if you want to view like the account page or like call an Uber, you have to authenticate, you have to log in. And so often this is like username and password is like the classic example of what we think of when we think about authentication. But there are also other ways of proving identity. And so, you know, username and password is like a knowledge-based test. Like, do you know the password that was used when this was set up initially? But passwords can be lost, they can be reused, and they can be breached across other places. So sometimes passwords aren't great because of just common practices across users. You should go buy 1Password for this reason. But there are also other authentication methods. So like, for example, proving that you own something, like email verification. Can you log into your email account and click on a verification link? Do you have a government ID which has your actual name and address that we have on file? Can you prove that you have that? So commonly username, password, email verification, phone verification, government ID verification. Then there are challenge questions. So again, this is knowledge-based, like where did you grow up? These are sort of being hopefully expired because everything's on the internet now and it's easy to research those questions, but those are there. And then within that, there's also kind of another layer. So who is the authentication provider? Who's the one who is deciding that this user is in fact them? So oftentimes there'll be like a delegation out to something like Okta or Auth0, and you may have a third party that is operating these authentication workflows. And within them, they will use these protocols, sort of like OAuth or SSO, SAML, and each of them are a little different. So username and password, it's common, but it's not always the most, it's not always the highest form of authentication. Things like leveraging another account, like a Google account that you can log in with, that's usually a higher form of authentication because there's just a lot more layers of security on that most typically. And then the government ID verification is can be effective, but it's very slow. So typically account login is like the classic type of authentication you would want to allow for something that's like a sensitive operation, like a user requesting access to their data or erasure of that data. But you can also then level that up with two-factor authentication, which is basically, in addition to that account login, can you also do email verification, or can you also do phone number verification? So you can sort of layer these together and create like higher levels of confidence in your authentication of that user. And that's important when you're doing very sensitive things like giving someone access to all the personal data in an account. So it's important to always try to use the highest form of authentication that is available. And so if that is available at your company, that's one method you could use. But sometimes you'll have users who can't do that, such as people who only on your newsletter. And then again, this becomes a question of risk. It's like, okay, how sensitive is the data of our newsletter subscribers? Usually it's not that sensitive for that subset of data. So maybe email verification, which is available, is sufficient in that scenario. So authentication, I would say in general, there's a lot of different methods, and it's important to think of it as something that can be layered for the more sensitive operations. And generally for those sensitive operations, always try to achieve the highest available method for each type of user you have.
That's great. And Pilar, as you think about authentication methods from your side of the house, what's one thing that you think folks should remember when considering different authentication methods for privacy infrastructure?
So when you are looking into what authentication methods you're going to use, a very important thing is you're most likely going to use a password. And if it's a password, you need to take into account, how are you going to store it? Where? How are you going to protect that information? Are you going to salt it and hash it? what functions you're going to use for them, because that is exactly the kind of things that can go wrong that leads to having leaks. There are ways to do authentication without you ever having the password, and those can be very valuable too. There's something we use called secure remote password, for example. In that case, the password itself is never sent to our servers. It's a much more complicated, so that's the trade-off, system in which both your device and the server talk to each other. They exchange an agreed upon secret in the middle, and they authenticate to each other. So not only is your device proving that it's the right one, the server is also proving to you that it's right. But whatever you're going to do, you need to make sure that you are keeping these passwords or this kind of information safe if you are going to store it in some way.
Great, that's super helpful. And just to set the context for folks as we think about authentication, because I want to move us on to our next piece. I know for some folks on the call, authentication may be occurring in more of an email back and forth exchange. And so what Ben and Pilar are really breaking down is when you start to bring authentication into your data privacy infrastructure, such that it's happening in an engineered format with automation, so that it can happen at scale. So this is fantastic. Let's move on to our next one because we've got a lot to get through, data systems. Ben, let's start with you. Can you walk us through the various types of data systems that exist and that hold personal data to give the folks on the call just a quick tour around how they would think about that?
Yeah. So there's kind of two axes worth thinking about. One is where it's stored, and then two is how it's stored. So on the latter, how it's stored, there's kind of two different types. One is structured data and the other is unstructured data. Structured data is relatively easy because it has like a format to it where it's very easy to know where certain types of information are stored. So for example, if you're looking for a person's data, right? Very often there is a format that you can follow, and it's a set of instructions that occur every time, and it's saying, we're going to go to this record, and then we're going to go to that record from there, and we're going to sort of pass through this like chain of data. Unstructured data, on the other hand, is very much unformatted. So you can think of like a Google Doc or a Word document or a chat app as just a lot of text that may contain personal data in it, but there's no clear, like, it's not sorted in any way. It's not categorized. It's not easy to discover. And the way you have to find it is by actually looking at all the content of the data to discover that information. Whereas structured, you can actually just use the format and leverage that, and it's a lot faster. The other axis is kind of like where it's stored. And I kind of think of this as really sort of like two or three categories. So one is your internal data systems. So this is either on-premise or on a cloud-hosted system like AWS, Azure, Google Cloud, et cetera. And in these systems, there are things that your engineers are building. So they are determining the means in which data is formatted, how it's being formatted in these systems. And within each of these, there's just like a huge array of different types of systems that can exist. You could have unstructured data there, you could have structured data there. But typically, the sort of common categories you could think of are your application database, which is like all the data that is running your app or service. Then there's usually a warehouse, which is sort of like copied over like analytics data. And that's just sort of like receiving data from your website and all these different sources. And then there's typically things that are generally called data lakes, but you can think of like Amazon S3 as an example. And that's just like a bucket of relatively unstructured data. And those are more like files, right? So those are the classes there. Then you also have a SaaS stack, right? And so this is often sort of overlooked in a lot of privacy, commonly in privacy programs, but it really shouldn't be, because oftentimes there's almost as much data there. And oftentimes it has like highly sensitive data or strong implications on users' privacy. So you can think of your SaaS stack as like your marketing systems, your CRM, your analytics tools, oftentimes your transactional emailing system. So the way that you send either like account confirmations or newsletters or what have you. Oftentimes all of that is done through third-party vendors. And so it's just as important to make sure that you're actually deleting that data from those systems when a user requests, or conversely, allowing them to access it, or just holding those vendors to the same standard of your security and privacy program. And there's sometimes some funny side effects of not doing that, where it's a very common thing to see, like a company will confirm that they deleted a user's data, and then the next morning they get a marketing message because it wasn't deleted from their vendor. So that's like, that happens. And that's just like one example of like the implications of not deleting data, but there's all types. It's very much a part of like the way that the user sort of like notices which data you've got.
True.
So
it's so true. And from the user perspective, it's not that they're actually gonna know if it's in a SaaS system or in an on-prem data store. They're just gonna see whether or not they had that experience of thinking their data was deleted and then getting an email or a notification a couple of days later. Pilar, from your side, what are the implications for SaaS companies or data controllers here as we pick up that last thread that Ben was talking about with the SaaS systems?
So one thing to keep in mind with all of these systems is you will have different parts of the company asking you to replicate and put the data in different places so they can use it for different things. But every single time you put data yet one more place, you are adding a new possible failure point. So the best thing you can do to decrease the risk that you have is be very mindful about how many places you are putting this data in. Wonder if there's a way that you can achieve your goal with the current systems without replicating it. And understanding that if you insist on putting it there, even if it's a very well-known or very well-respected system, nobody is immune. So when you have all this data moving everywhere, you are increasing your risk every single time.
So important. And as you think about, Ben, this is a question for both of you. One thing to remember when we're talking about data systems, we've covered so many terms that I just jotted down, everything from unstructured to structured data, thinking through, and I think we've unlocked on-prem, which gets thrown around as shorthand, on-premise data stores. What's one thing that you think folks should take away from understanding how to talk to an engineer about data systems as it relates to privacy programs? Go ahead, Ben. I see you tip of your tongue with something.
Sure. So I would say the main thing to remember is just that there are a lot of different strategies for each of these systems, and it's going to be a mixed approach. Like there's no like one shot, like perfect, like simple function you can write on one system and call it a day. It's going to be a mixed strategy where you're connecting to every data system you have, and to be able to regulate that data, it really means like a pretty like wide solution that has a lot of different strategies in it. So unstructured data means you're doing content searching. Structured data means you're using indices. Integrate SaaS tools means you're building API integrations or using someone else to help you do that. But it's a very mixed strategy, and there's a lot of different systems. It's good to brush up on that when talking to engineers, especially the ones that we went over. Those are by far the most common. So
great.
And just another left side of this is you must assume that once the organization is used to having a certain kind of data, it's going to stay that way. So you should build your systems. What we do is privacy by design. Think and really decide if you really want to need this data, because you're taking a very big responsibility of taking care of it. Make sure you really need it enough that you are willing and prepared to take this responsibility.
That's great. It's really helpful. Let's move on to our next topic, another good and thorny one, encryption. So Pilar, we're going to start with you. Now, this, from my perspective, is a term that gets thrown around so much. Can you just break it down? What is encryption? Talk us through what it is and kind of give us the highlights so that we can understand what's like myth versus fact here on encryption.
I like this one. Okay, so I will back up a tiny bit to put it into context. We were talking about authentication before. Authentication is, in the analogy I'm going for, showing that you have the right to get into a room because you know the special word or something like that. Encryption is actually taking data, manipulating it with some special math usually, and then what you need to do is know the special key to be able to put back together that puzzle that you had scrambled up before. So that is a pretty important thing to know. Technically speaking, if you have something that was encrypted correctly, it can be in front of you and you will not be able to get anything out of it. You can even have a hiding in plain sight kind of thing because it's encrypted, because it's not just hiding behind a veil. The actual data has been modified and scrambled up. A very basic, old-fashioned kind of encryption is a simple substitution. If you have just a text, you change every A for a C, every B for a D, and so on. This one is easy to decode if you know how some things work. That's not true with modern encryption, but the idea is the same. You have your data, it's on your computer, so at the end of the day, it's just ones and zeros. And you create a number that is as random as computers can make, which is a very specific kind of random. And you are the only person who knows that big random number. So you combined together your data with this big random number, and you end up with something that the only way you can get any value out of is to combine it again with another number that will get you the right kind of thing that you need. So that is that's like the analogy, that's like the base of what encryption is. And that is why it's so important. Now, when you have an encryption-based system, you do have keys that you use to encrypt the data. This especially large number, and these keys need to be stored somewhere. They need to be taken care of. So when you are designing an encryption-based system, you don't only need to decide what algorithm you are going to use. And by the way, don't roll your own crypto. There are some very specific standards libraries that have been very well tested and documented. Use those, because bad things happen when you try to do your own crypto. But then also consider what you're going to do with key management. In other words, are you going to have the keys for the data in your own server and send it in some secure way to the customer? Or are you going to let the customer fully manage them? If you have the keys to the data, it means you can still access their data, And depending on what kind of service you have, that might be fine. If you let the customer, and by the customer, I also mean their device, they don't need to know that your app is doing that in the background. You won't be able to access their data, which is fantastic. But if they lose access to those keys, there is no way for you to help them, which I don't know, for 1Password, we believe that is very much a valid trade-off.
That's very, very helpful. And I think that kind of brings us to a good question that I have seen a lot as a non-technical person. So Ben, I'd love for you to break this down for us. There is a difference between end-to-end encryption and encryption in transit at rest. Yet I think a lot of stuff just gets thrown under the terminology of we have encryption. So can you break us, are those things different? If so, how are they different? Can you break that down for us so that we can all walk away with a sense of how far apart those two concepts are?
Yeah. So yeah, a lot of people just say encryption. And if you think of encryption, basically there's like a lockbox, right? And you store secret information in that lockbox. It's like the world's best lockbox, and there's a key to that lockbox, right? And so end-to-end encryption is like, I want to send this lockbox with my secret, let's say on UPS, right? We're just going to like ship it somewhere, but we don't want any of the people transporting it to be able to open that lockbox. So I lock it with my key, and the person I'm sending it to also has a key for the lockbox. If I lock it with my key, we can like ship it, and no one along the way can unlock it. That's what end-to-end encryption is. It's basically saying only the people sending it and receiving it have the key to unlock this. Encryption at transit and at rest is saying, I'm going to give you my secret, UPS, and UPS is going to take their key and lock it and then ship it. And then they're going to unlock it and then give it to the person, which basically means there's a difference in trust on end-to-end encryption versus encryption in transit / at rest, where it depends on who has the keys, right? So is it the shipping company that has your keys, and are they just storing it on your behalf? Or are you locking it yourself and then not trusting the person shipping it? So in Transcend's context, that means we use the end-to-end encrypted model rather than just encryption in transit and at rest. It means that the company that's sending a export of user data to the user, they're locking that data before they pass it to Transcend to transfer out to that user. So Transcend is sort of like UPS in this example, where the company locks it, we ship it, the user unlocks it. Whereas in a more naive model, the company may send the whole user export to the third party. The third party would then lock it so that they can say that they use encryption, and then they would unlock it and then pass it on. And encryption in transit at rest is, to its credit, still important because it protects the data from malicious like hackers and things. It helps bolster that security, but it's a different model of trust. So if you don't want to trust the shipper, use end-to-end encryption. And so it's sort of like thinking about Signal as a great example. This is like a real world example of this, is you lock your message, the person receiving it unlocks it.
That's super helpful. We've gotten some questions just from the audience around zero trust and security in general. So what I'm sort of taking from that, end-to-end encryption is in the zero trust ethos, to your point, like don't trust the shipper, right? Have a system from when the data leaves your systems to when it gets to the end users that it has sort of protection across, versus that kind of locking of the lockbox. Anything else that you would layer in there for security and zero trust, Ben, as you're breaking down those two differences, or Pilar, please feel free to jump into there.
Yeah, so something I like to say about zero trust is what it means to have end-to-end encryption with keys that we never have is that you don't have to trust me, you have to trust the math. So as long as you can trust that math and science are right, you don't have to trust the individual companies that are giving you the services. Ben gave the example of Signal. there's one that is even a little bit more funny in a way. WhatsApp is also end-to-end encrypted, and it belongs to Facebook. And you can say you don't trust Facebook, but if it's end-to-end encrypted, as long as the encryption was done correctly, you don't need to trust Facebook because you are trusting that the math of the encryption was done right.
That makes sense. Whereas if it was encrypted at transit and rest, Facebook in this entity would have the keys, as we've been talking about, to unlock or lock as we go. I think that's super helpful. Let's just quickly touch on Transcend and 1Password, because I know you guys both have end-to-end encryption. So Pilar, let's just start with you very quickly on your 1Password approach. Is there anything that we haven't covered that you think is worth noting before we move on to our next section?
Well, 1Password started as something that was just stored locally. And when it was decided that we were going to move it into the cloud, the one thing that we were sure of was we need to make sure that it is safe from everyone, even if we're going to do absolutely everything to protect our servers. But we want to build something that is so strong that even if the actual servers were compromised, data wouldn't be. So we went a bit of a step further in our implementation of end-to-end encryption. We have what we call a two-secret key derivation. And what that means is you still get to choose your password, your master password, but you might choose a really bad one. You might choose your full name followed by your birthday. And because we don't know it, there's no way we can know it's that bad. We still want it to be secure, so we generate something that we have called the secret key. Basically, this is a high entropy secret that gets combined so that trying to brute force or to guess the entry into 1Password is basically impossible. And just to finish making the bridge here, entropy is, in few words, how we measure how hard it is to guess a password or not. It's something that you can actually do the math and the computations of that.
That's great. Awesome. Ben, anything quick from you before we move into the next piece?
Yeah, so end-to-end encryption is like one part of what zero trust means to Transcend. So end-to-end encryption is just, we don't see the data that we're transferring. But because we're also a system which runs the processes of finding data, there's also, in a naive approach, you would actually, as a company trying to build that, in the naive approach, you'd say, give us access to that system, right? And then we'll go through it and find it. But that would violate this zero trust thing that we wanted to build. So, so we actually don't store any of the keys into like those systems. So let's say it's your Salesforce account. We don't have your Salesforce key because that would mean we could access your Salesforce. So there's a lot of complex stuff that I probably shouldn't go into, even though I could probably fill the rest of the time talking about this. But we have a way where we essentially delegate all authority to something that our customer owns, and they keep their keys on their systems. And we essentially coordinate with that system to ensure that we can still make the request to Salesforce and then receive that sort of like encrypted version of it so we can transfer it to the user. So end-to-end encryption is kind of one piece of it, and it's an essential part, but the other part is not even having the keys to the downstream systems themselves. So
that's great. Thank you. There's so much meat here, so we're just going to keep flying through. I want to quickly touch on our next topic, structured versus unstructured data. Ben, just in a moment, give us the takeaway for lawyers on the challenges of unstructured data versus structured data.
Sure. I think I may have skipped ahead a little on my last one, so I'll keep this one brief. So structured data is the data that's like well formatted and relatively easy to operate on because you know where the person exists inside that. So we're talking about personal data here. Unstructured data is messy, unformatted, and you have to essentially search through all of the data to find things that relate to the user. And so that means it's slow. And oftentimes, in a lot of implementations, it will be a little bit subjective, right? Like if you have like John Smith, one of the most common names in the world, sitting in a Google Doc, is that really the John Smith who's asking for their data, or is that like one of the other 9,000 of them? And so there can be subjective interpretations that have to be made when you're operating on unstructured data. But structured data is typically things that can be very easily automated. So that's how I'd think about it. There's more layers, but I'll keep this one.
I want to take a moment on that. You said unstructured data can be automated, right? That tends to be a myth that we hear a little bit in the field, that unstructured data cannot be operated on.
Yeah. Well, you can operate on it manually or automatically with constraints. So if you are doing things like searching for universally unique keywords, such as a fully formed email address or a user ID, then there's no subjectivity to that. That is the user who is requesting deletion. But if you want to also look for the full name, then that's by its nature a subjective decision on whether this person is in fact the one requesting it. And so with the right constraints, you can actually automate your unstructured data processing. But it will depend on the constraints. Yeah.
Perfect. Great. Data erasure and pseudo anonymization. Pilar, what are some constraints to think about when talking about the erasure of personal data?
So a very big one is that you will need to keep some data for one reason or another. You can basically never actually, at the moment, erase every single piece. And a great example of that is backups. If you have your immutable backups, you're not going to go mess with them. That's how you end up with backups that don't work and with costing your customers probably all of their data. That is a really terrifying thing. If you think about the way snapshots in AWS work, they basically take little screenshots of the way the entire database looked at a point. So if you make a change like erasing it, you erase it from now on, but you cannot go and manipulate what is stored in that backup that tells you how the database looked like 2 weeks ago. So whenever you tell someone that you're going to erase their data, you almost certainly have to make it clear that you are going to keep it in backups and how long that is. Usually it's not something too out of mind. In our case, it's 35 days. So that still works. And another example is sometimes you have, even from the same place, kind of conflicting laws or conflicting guidance of what you can erase and what you can keep. So they will ask you to erase everything from a person, but then they will also ask you to be able to show where your money came from with a certain amount of detail. And you can do one or you can do the other, but you cannot do both at the same time. So keeping that kind of thing in mind, you will erase everything you can, and then you will document what you didn't and why.
Perfect. Thank you. Let's move on to our next topic, which is around APIs, webhooks, Kafka, a ton of terms that we hear thrown around from the non-technical side of the house. Ben, let's start with you. Can you break these down for us super quickly?
Sure. So you can think of these terms as basically like connectivity software. So it's ways that systems coordinate with each other. Virtually every company leverages these types of technologies and has to talk with other systems. So internally, you may have many systems that coordinate with each other form the service, for example. And so when you're thinking about something like an erasure workflow or a data download, you're often coordinating across many, many systems. And the way that that will happen is there is some sort of like main system that is coordinating that request, and it will be coordinating with each of the system's APIs. So if you have a data system or a SaaS vendor, the way that you talk to them programmatically is by interfacing with their API or application programming interface, which is basically just like, here's our menu of things you can do with this system. And like the system talking to it is basically ordering from that menu. So that's how you think about APIs. Webhooks are similar in that but they're more like notifying other systems of things to do. So if you are saying, if you have some service that needs to be able to receive a job to delete data on it, you may think of implementing a webhook to ping that system and say, there's a new erasure request from Andrew, let's get that deleted. So APIs and webhooks are very, very, very similar, but one is more like there's a menu available. Webhooks are more like you're sending a notification. Kafka is a much more complicated concept, and I don't want to get too deep into it, but you can basically think of it as a way of running a workflow across a lot of systems. So it's more like that backbone thread that is coordinating across a lot of other systems. It's kind of similar to that other like main thing where there's all these APIs that your sort of main thread is talking to, except it's sort of inverted, where Kafka is something that all of those different services are reading from. And so they're saying, oh, there's a request, let's pull that in and let's do the job. So it's sort of like pulling from the main sort of process thread. But generally, just think of these terms as the way that your many systems and many SaaS tools will work together to solve a problem like deleting personal data.
That's so helpful. Thank you. Pilar, we got a question that came in around re-architecting a non-compliant system. I have to imagine connecting some of the applications together is helpful, but when you think about starting from a data system that is either messy, perhaps has some security issues, you could be looking at, perhaps a company that's kind of grown and fits and starts, and so it has added all these appendages on. Anything you would offer in terms of just quick advice for thinking through how lawyers can start those conversations for the re-architecting of a system that is a little bit more compliant, a little bit neater, a little bit more privacy by design?
So I think a very important thing to this would be, if you already have a big messy system, don't keep on adding things to it, hoping that the additions are going to automatically solve the mess. You need to start with a good base before you can then take something that will rein everything back in. Otherwise, you can very easily end up in one of those situations where the only thing you managed to do was get yet one more appendage to your system, and that is not going to help you as much as you think it is. And yeah.
That's great. Thank you. Let's go over to our last one, querying data, deterministic versus non-deterministic. Going to take a quick beat here just for folks listening in. If you do have a question that you want to add, we're going to squeeze in 4 minutes or less all of the speed round. So please feel free to drop that chat in. But Ben, speed round starts early, deterministic, non-deterministic. Can you explain the difference for us in a sentence or less?
Deterministic is consistent and repeatable queries. So if I delete a user, I always delete the same data, or if I download a user, I always get the same data. Non-deterministic is fuzzy. So it changes and it's not precise. This screenshot is hilarious, by the way. Demolition crew knocks down wrong house after Google Maps mix up. That's the kind of thing you don't want to do when deleting a user, right? So don't delete the wrong account. Don't return the wrong data to that user. So go for deterministic. It's much better.
Amazing. Great. And let's start with the speed round again. Drop anything in chat or jump off mute if you want to just throw it in. Pilar, in a few words, what's one thing you should remember about privacy engineering?
It isn't magic. It might seem like it, but it isn't magic.
I love
if
that.
you need something from the engineers, it's going to take planning. It's going to take time to develop it properly. And there is a chance that you're asking something that is like technologically impossible. So there is even a chance that it will not be doable. So keep that in mind. It's not, if you ask for something at 4:30 p.m. on a Friday, don't ask on Monday at 9:15 where it is. That's not going to foster a good relationship with your engineers.
I love that. Great. We heard one from Melanie in chat, so I'll just throw it in. Ben, what's one engineering concept you wish lawmakers understood?
I would say that I maybe start with like just privacy by design better. So like actually the fact that there is data minimization to be had, and I think they generally understand this, but I think there's a lot of maybe lobbying powers that say it's impossible because there's so much data, but that doesn't have to be a given. Like there is a lot of data because there was no regulation before, and I think it would be helpful for lawmakers to sort of understand that it's not the end of the world to collect less, and that is often very much a possible thing. So
that's great.
I would start with that. Yeah.
What's one thing I can do tomorrow to be a better partner to privacy engineers? I feel like we heard a great answer from Pilar on that. It's not magic. Don't ask for it on Friday. Be succinct, to have details. What's one question to ask a privacy engineer in my next conversation? Pilar, what's one question you would hear? And we'll leave it at this as the last one.
So this one's a little bit different, but it will probably help you see where where the engineers are coming from. Ask them for their favorite example on how that data was used or combined in a way that was not supposed to, and that ended up with people learning things they shouldn't have. We all have a couple of favorite ones. They can be from the world, they can be from something that happened internally, and you will probably get some interesting stories out of this.
That's fantastic. Well, thank you both so much. We put in a lot in an hour. We are going to send out a recording of this. We also have a PDF resource that breaks down a lot of the terminology we discussed. I'm sure we could keep going for a lot longer, so feel free to drop any questions, and we'll get back to you with answers if there's anything else that popped up. But I hope you walk away from this knowing details matter. There's a lot of terms, and the more you know them, the more informed your conversations can be, and that there are ways to help advance your privacy program using engineering at its core. So hopefully this was valuable. Thank you for spending the hour with us this Thursday morning. We really appreciate it. And I hope you guys have a great rest of your day. Thank you for joining us. And thank you, Ben and Pilar, for offering all of your expertise.